Hi, in this video, I'm going to go over the MLflow capabilities within Azure Machine Learning Workspace. So MLflow is an open source platform which helps streamlining your machine learning development workflows. So MLflow initially started, with supporting your traditional machine learning development workflows, but recently they've also started providing capabilities and tools to support your generative AI applications and AI agents as well. Okay, so in this video, I'm just going to focus on the traditional machine learning aspects. Okay, so MLflow, right? So there's various components that makes up MLflow. So MLflow has a client SDK which is offered in different languages. In this video, I'm just going to use the Python SDK. Okay. This MLflow client SDK is what you use to interface with the tracking server. Okay. There is also the backend store, which is like a database that you can use to store your metadata of experiments runs. It can also use the file system. Okay. There's an artifact store which can be used to store your artifacts that you generate, like your files, other things as part of your experimentations. Okay, and there's a tracking server which is a fast API server and that offers that serves various REST API endpoints to access your backend store or the artifact store. The tracking server also hosts the MLflow UI. Again, there's also MLflow Model Registry, which I'm going to cover later in this video, which is also kind of part of the same deployment. Okay. There are various ways you can use these MLflow, right? So you can do pip install MLflow, and then you can use your local machine, again, to store your artifacts, to store your metadata, right? So you don't need to configure anything. Right out of the box, you can just again, use the MLflow client SDK, log your experimentation runs, and then use the local server as your remote tracking server. Okay. I mean, if you want, you can also configure a local database to store your metadata as well. Okay. At the same time, you can also deploy these MLflow as a remote tracking server. So there's a set of databases that are supported by MLflow, and even the cloud storage accounts, right? So you can configure and you can deploy a tracking server on a VM or or wherever on your cloud services, right? You can deploy that, and then it's not just you, right? So your team can also leverage the same remote tracking server, right? Again, there's a lot of setup that you also need to do, right? So you also need to control the access, like you also need to manage the access controls, security and other things as well, right? So there's also managed services. Okay, so for example, Databricks, right, which is the one behind creating these MLflow, right? They offer MLflow, like managed MLflow service, right? So you don't need to do any extra configurations or deployment, right? So the MLflow tracking server comes out of the box. Okay. Similarly, Azure Machine Learning offers the MLflow tracking server. So when you deploy an Azure Machine Learning workspace, you can also just use the MLflow tracking server out of the box. Okay, you don't need to configure anything. Okay, so in order to use the MLflow tracking server within the Azure ML workspace, you just need to make sure that users have access to are given permissions, right? So in your role-based access controls, in your role assignment, right, just make sure that that role has these permissions listed, right? Again, there's a few things for the tracking server, there's few things for the model registry, a few operations, right? So the user need to have the sufficient permissions to do those operations. Okay. Another dependency is you also need to install the Azure MLflow Python package in order to use the MLflow. Okay, so these are the two requirements to use the MLflow tracking server on Azure Machine Learning. Okay, all right. So what I did was, I've created I have a Visual Studio Code session open. I'm running on the Azure ML Compute instance. I've established a remote session here. Okay. I've created a Python environment, and then I've installed the necessary packages. Okay, so I've installed the Azure AI ML Python SDK, which is the V2 version, right? And then Azure MLflow, and then the MLflow package itself. Okay, I've also installed the Azure Identity Python.env. Okay, I've also installed the scikit-learn, pandas, and matplotlib libraries. Again, this is more from a data science experimentation standpoint. Okay. All right, so let's have a Python module created, main.py. Okay, I've imported the the dependencies from those respective libraries. Okay, let me run this. Let's go to the next cell. So what I'm doing is I'm creating the ML client. I'm passing the default Azure credentials, subscription ID, resource group, workspace name, the ML workspace name details, right? To create an ML client. Okay, and then you can use the ML client to fetch the MLflow tracking URI, and then you need to set your tracking URI before you want to use your MLflow tracking server. Okay, so what I'm doing here is I'm setting the remote tracking URI to the Azure ML provided tracking URI. Okay, and then I'm using the scikit-learn make datasets make classification. Okay, function to create a dummy dataset with 5,000 samples and then 20 features. And then I'm using the train test split function to create the training and test data sets. Okay, and then I'm going to give a prefix called MLflow demo. I'm creating a variable here. Okay, so the MLflow tracking, right? So let's say if you're working as a data scientist, right? So you might be trying out different algorithms, right? Or you might be trying out different hyperparameters for these machine learning algorithms, to come up with the right machine learning model for that for the data that you're working with, right? So you are kind of in an experimentation mode, right? So you are trying out you're doing multiple runs with those tests, right? So you can use the MLflow tracking server to log all of those runs, right? So instead of saving these metrics, parameters, and all that in separate files, right? You can just use the MLflow tracking server to save all those run related metadata. Okay. All right. So let's see these in action, right? So I've created an experiment, calling it MLflow demo manual logging. Okay. I have a set of parameters defined. These are fixed parameters that I've defined. And then, I'm using the MLflow dot start run to say that, I'm going to start this particular run under the experiment. Okay. I'm going to log those fixed parameters using the log parameter method here, right? I'm creating a random forest classifier from scikit-learn, and then I'm using the training data to fit the model, and I'm using the the trained model to make predictions on the test data set, and then I'm using the accuracy score, FN score functions from scikit-learn to calculate the accuracy and FN metrics, and then I'm using the MLflow to log those metrics. And finally, I'm creating a conversion matrix. Okay, again, same using the scikit-learn functions, and then I'm creating a PNG file, and then I'm using the MLflow log artifact to log that particular artifact. Okay, and finally, I'm using the MLflow.scikit-learn.log model to log this model to this particular run. Okay, so everything is if you see this, right, everything is running in the with context here. Okay, I mean, if you want, you can also do MLflow dot start run and end run, right? So, but here, right? So I'm just using the with context here. So let me run this. Takes a minute or two for the experiment to run. Okay, it finished running. Let's go to the Azure ML workspace. Let's go to jobs, and then experiment. You see the MLflow demo manual logging. So this is the experiment name that we set using the MLflow APIs. Okay, then if you click on this experiment, you see the run. So this is the run that I'm referring to, right? So, and then if you click on the run, you see the parameters that were logged using the MLflow APIs, metrics that were logged, as well as the artifacts, right? So we created a confusion matrix PNG file, and then the model itself, right? This is the MLflow model. Okay, I'll go into more details later in this video, but basically, we were able to log all of this using the MLflow APIs, right? And then you can use the UI here to see all of those details, right? Right. So maybe this is one run, right? So you can also I've changed the max depth from 5 to 10, right? I'm going to use the same experiment and then run this again, right? So again, I'm trying to simulate how you do your experimentation, right? So you try out different parameters, right? So that's what I did with this particular run, right? So I changed the parameter, the max depth parameter from 5 to 10, and then started the run. Okay, so it finished running. So let's go to the Azure ML UI again. Let's go to jobs, this particular experiment, right? So now you see a different run, right? Let's click on this particular run, and you see the max depth was changed from 5 to 10, and then you can see the metrics, the same thing, right? So you can also see the model that was trained with those parameters, and then the artifact as well. Okay, and with the MLflow UI, you can also click on the dashboard view. You can see these runs. You can also see compare the jobs as well, right? So so if you have more and more runs, right, so you can just come to this UI, and then you can compare those different runs. Okay, so that's the beauty with the MLflow tracking server. Okay, all right, so let's go to the Visual Studio Code again, right? So here what we did was we kind of logged everything manually, right? But MLflow also provides the capability to do auto logging. Okay, so since I'm using the scikit-learn library here, so there is an auto log is supported with scikit-learn. So I think there's about 20 plus frameworks supported by MLflow, which has the auto logging capabilities as well. Okay, so I've specified the parameters again, same as above, right? And then I'm again training the random forest model. I'm just using the model.fit, right? I'm not doing anything. I'm not logging any parameters. I'm not logging any metrics. I'm also not calculating any kind of accuracy metrics as well, right? So if I run this, right, so it finished running. Let's go to the Azure ML UI again. So refresh. So you see the MLflow demo auto log. So this is a new experiment that got created. And then if we click on the run, you see a lot of parameters that were logged to this run, as well as the metrics, right? And then you can also see all the artifacts and the model that were logged, right? So again, we didn't do anything, right? All we did was we used the auto logging capability from MLflow, and then everything kind of logged automatically. Okay, so this is helpful, right? So you don't need to kind of do any manual things as well, right? Okay, so let's disable the auto logging. So we can use the mlflow.scikit-learn.autolog disable equal to true. Okay, again, just to make sure that we're not doing any kind of auto logging. Okay, so now there's also something called model evaluation. Okay, so basically, right, so in the previous examples, we have used the scikit-learn metrics to calculate the accuracy metrics, right? But there's also this mlflow.models.evaluate, again from the MLflow APIs, wherein you can pass your evaluation data. So evaluation data has your predictions as well as your target values, right? You can pass that, and then you can map your predictions and targets here. And then the model type, you specify the model type as classifier, right? So when you do this, right, so all of these metrics would be calculated automatically, right? So these are like evaluation metrics, right? So those would be calculated automatically by MLflow APIs, and then going to be logged to the run. Okay, so let's go to the UA again. Let's go to the model training and evaluation. Let's click on the first run here. Okay, so now you see all of these metrics that were calculated automatically. Okay, and then if you go to the outputs, right, so we've only generated the, so I mean it created the confusion matrix as well. Okay, again in this particular example, right, so we haven't logged the model, so that's the reason you don't see the model being logged to the run. Okay, so this is another way to to generate and log your metrics to the experiment run. All right, MLflow also has the ability to you can also use the MLflow tracking APIs to log nested runs. So for example, when you're doing the hyperparameter tuning, right, so you might be trying out different hyperparameters for your models, right? All of those can be bundled together into a single run, okay, as part of the experiment. So you can also do that with the MLflow tracking server. Okay, so what I did was I created a parameter grid with a set of values for each of those fixed parameters that I defined above. Okay, and then I've created a parameter grid again just to simulate how these nested runs work. Okay, I'm going to again get the combination of all of those parameters, train the random forest classifier, calculate the cross validation score for that particular trained model, as well as the cross validation, the mean accuracy and then the standard deviation. I'm going to use the model to make predictions, calculate the accuracy and the FN score, and I'm going to log everything for that particular run. Okay, I've also created a best run accuracy, right? So again, just to find out the best run from all of these combinations, right? And then finally, I'm going to log the best parameters, like the parameters and the metrics for the best model out of those combinations to the parent run. Okay, so if you look at it, right, so this is going to be logged at the parent run level, and then these metrics are going to be run, going to be logged at those child runs. Okay, so let me run this. Okay, so it finished running. As you can see, there's multiple runs that got created. Okay, so let's go to the Azure ML workspace. Let's go to the, so you see this is a new experiment that got created, and then you have a run, and within this run you see all of these child runs, right? So let's click on the parent run here. So if you look at it, right, so we have logged the best run accuracy and the best parameters out of those combinations, and then you can also see all the child runs as well, right? So basically you can also use the MLflow tracking APIs to do this kind of experimentations as well. Okay, at the same time, again, you can use the MLflow UI to within the Azure ML workspace to compare your runs, right? You can do the job comparisons as well, right? All of that can be possible with the the MLflow tracking server on Azure ML. Okay, all right. So in one of our previous runs, right? So I was showing you. Let's click on this particular run, right? So if you look at it, right, so we have logged the artifact, and then we also logged the scikit-learn model, right? So this is, so MLflow model is what this is called. So this is another feature from MLflow, right? So what MLflow model, the idea of MLflow model is, right, so it kind of brings some uniformity in terms of how you can how you log your model, right? For example, if you're using PyTorch to train your model, or maybe if you're using the Spark ML to train your models, right? You can create an MLflow model that kind of looks similar, right? So basically, it brings uniformity on how you package your model, right? So that your downstream tools, when it comes to deployment, right? So it brings that uniformity and then streamlines the process of managing your models across different frameworks, right? Okay, so when it comes to the MLflow model, there are various components as part of the MLflow model, right? One is your package dependencies. So your package dependencies would automatically be logged to the MLflow model from your runtime. I mean, you can also pass these dependencies when you log your model manually as well, but it does pick up those dependencies in the Python environment that you see, right? Requirement.txt, Python environment, right? All of those would be logged to the MLflow model along with your model file, right? So since I've used the random forest classifier, right, it created the pickle file, right? So that is going to be logged. And then if you look at the ML model file, right? So this is the core of an MLflow model, right? So this is like a schema, or this is what makes this particular folder an MLflow model. Okay, so here you have the link to the artifact path, and then you have different flavors, right? So flavors, kind of again brings some abstraction, and then bring some uniformity around how you consume these models, right? So for example, I've used the MLflow scikit-learn flavor, right? So I can just use the MLflow.scikit-learn load model or log model to log this model, right? And then these flavors bring the uniformity, so it kind of abstracts how you package your model, how you load your model object, right? So it's all abstracted away from the user, right? And then you can use common interfaces to make predictions using this loaded model. Okay, again, it's more about streamlining, it's more about bringing uniformity in terms of how you manage your machine learning models. Okay, again, along with this, we also created signatures. So if you go to the MLflow this model, right? So I've also passed the input example here, right? So this is what generated the signature. So basically, signature is like your API contract, right? So it says this is what this model is expecting, right? So whenever you use the MLflow to models to make predictions, you can, the data validation happens, right? So if the format of the input is not what the model is expecting, it would throw an exception. Okay, so I mean, you can create those signatures. You can use by using the test data set, or you can also provide the signature details as well, when you kind of log your model. Okay, and then the input example. Okay, so this is the test data set that we have used when we log the model, right? So basically, this created the file. This also